Hey all you cool cats and kittens. These are the notes for Lesson 22, Scale Drawings. So before we jump into this, I want to take a second to review what a ratio is, because this lesson is all about ratios. So a ratio is just, it compares two numbers. And you can see it in three main ways. Like sometimes you'll write like 1, 2, 3. Sometimes you'll write it like a fraction, 1 to 3. And sometimes you'll write it with this colon right here, 1 to 3. Most of the time we're going to see it like this in this unit, but I personally like this one the best, and we're going to use this one. So you'll see it like this, and we're going to change it into this oftentimes. So let's look at this prereq. So suppose you want to enlarge a 4-inch by 6-inch photograph as much as possible so that it fits on a bulletin board that's 24 inches high. What is the widest the photograph can be? So we've got, it used to be 6. We're blowing it up until it's 24. It used to be 4. We're going to blow it up. How big is this? That's what we're trying to find. I'm going to put X there. So let's look at this. What's the ratio? Remember, we're going to write it like a fraction or with words or with colons of the height of the original to the height of the enlargement. So this is 6 to 24. Or we could write it like 6 to 24. Or we could write it as 6 to 24. You don't need to write all 4 or all 3. You can just pick one of them. Now we want to say, what's the ratio in simplest form? Look at this fraction right here, 6 over 24. Can you reduce that fraction? Heck yeah, you can. We'll divide both by 6, and we get 1 over 4. So this is my ratio in simplest form. Now we're going to find equivalent ratios. That means they're the same thing. So like 6 over 24 is equivalent to 1 over 4. And we can find these other equivalent ratios by finding, let's see, this is 6 times 4 and 1 times 4. Let's do 2 times 4, 3 times 4, 4 times 4, and 5 times 4. If you reduced any of these fractions, they would all reduce to 1/4. So they're all equivalent. So the relationship between the measurements of the original photograph and enlargement are proportional. It's proportional. So what should the width of the enlargement be? The width was 4. How big is the width over here? Well, instead of height, we could just change this to width, since the proportional means we're going to still use these same equivalent ratios. So if it was 4, if the original was 4, that means the enlargement must be 16. And these are all in inches. How many times greater is the width of the enlargement than the width of the original? Well, how do we get from 4 to 16? Multiplied by 4. So how many times greater is it? 4 times greater. And this last one is my favorite one. Explain how you could find the measurements of an enlargement if you know the ratio of the measurements of the original to the measurements of the enlargement. We're going to use the hashtag method. And I'm just going to let you write that right there, and then we'll come back and I'll give you a couple examples of it in a minute. But before we do some more math, let's talk about some vocabulary. So an enlargement is an example of a scale drawing. A scale drawing shows an object with its measurements in proportion to the actual measurements of the object. The best way that I can describe a scale drawing, think about blueprints. So you can't actually draw out like a 40-foot building, but you could draw out a 40-foot building in a smaller scale as this scale drawing. So a scale is a ratio that compares the measurements used in the scale drawing with the actual measurements. So we found on this back page that the ratio was 1 inch to 4 inches. So the scale is the ratio 1 to 4 from original to enlargement. So scales can be given the same units, like right here we've got inches to inches, or it could be different units like we'll see down here, inches and feet. A scale factor is a constant of proportionality. All that means is, let's see, first of all, we have a proportional relationship, which is why we can use a proportion or a hashtag. And the scale factor is the 1 to something. So we saw before that the ratio could have been 6 to 24, but this isn't the scale factor because it's not a 1 to something. When it's 1 to something, that makes it the scale factor. So the scale could be 6 to 24, the scale factor is 1 to 4. So scale drawings are typically used when objects are either too big or too small to be drawn in their actual sizes, like I said with the blueprints. Maps are scale drawings also. You know, like think about Google Maps. You're not actually looking at a mile on your screen. You're looking at like a centimeter that's equal to a mile. And you can see that in the bottom corner of your maps. Architects use scale drawings when they design buildings. Floor plans and maps are drawn smaller than actual size. Drawings of cells in biology are drawn larger, so those also have a scale. So the floor plan shown is an example of a scale drawing. The scale 1 inch to 10 feet can also be written as 1 inch equals 10 feet, or it could be written like 1 inch over 10 feet. That means that 1 inch in the floor plan represents actual distance of 10 feet. So what's the scale of a drawing that shows 2 inches when the actual length is 36 inches? Well, we're just going to put 2 to 36. And these are both inches and inches. We could also write that as 2 to 36. Again, we probably should have the inches to inches. Or we could write it as 2 over 36. Looking at it as a fraction is easiest to tell that, hey, I can also divide by 2, divide by 2. This is 1 over 18. So I could write all of these as 1 inch to 18 inches, or 1 to 18, or 1 to 18. This over here is the scale. This right here is the scale factor. 18 is the scale factor. Okay. So let's see some examples. So we kind of know what it is now. How do we use it? Below is a scale drawing of a soccer field. The length is 1 centimeter. Let's see, a length of 1 centimeter in the drawing corresponds with 15 yards in the actual field. So now we're seeing different units, but it still works out. Find the dimensions and the area of the actual field. So we need to find the length, the width, those are the dimensions, and then we need to find the area. All right, so we know that the scale is 1 centimeter corresponds to 15 yards. So that's 1 centimeter to 15 yards. And we're going to use this scale to find the dimensions. And like I said, we're going to set up a hashtag. So in your hashtag, you're always going to have your scale as one of the like fractions of the hashtag. And then it's going to be equal to. And let's see, let's try to find the length first. So it used to be 8 centimeters. So see where it's centimeters, we should have centimeters up here. That's a good indication. But if you have the same scale, remember that this is like the scale, this is the drawing, and this is the real. And that's how we set up the hashtag. The drawing is all right here, the real is all right here. This is the scale, this is the field. So 8 centimeters equals how many yards? Well, I'm going to call this x, and then we're going to cross multiply. 8 times 15 equals 1 times x, and 8 times 15 is 8 times 15, 120. So it's 120 equals 1x, and I'll just divide by 1. So we get that x equals 120. That means the length that in the drawing is 8 centimeters is actually 120 yards. We can do the same thing with the width. I'll set up my hashtag, 1 centimeter over 15 yards equals, so this is the drawing, this is the real. In the drawing, it's 5. We're trying to find the real. So we'll cross multiply. 15 times 5 equals 1 times x. 15 times 5 is 75 equals 1x. Divide by 1 on both sides, and I've got x equals 75. So the width is actually 75 yards. Last but not least, we want to find the area. So that's 120 times 75 since it's a rectangle. So length times width. And the area is 9,000 yards squared, square yards. So let's try a couple more. In a scale drawing, the building is 5.5 inches tall. If the scale is 1 to 8, how tall is the building? Well, we're going to put our scale, 1 inch to 8 feet. And let's see, I'm looking at a building that's 5.5 inches in the drawing, so that's the top here. So that's 5.5 inches over x. So we're going to cross multiply. 8 times 5.5, 44 equals 1 times x. We can divide by 1 on both sides, and I get that x is equal to 44. And then let's just think about our labels right here. It's inches, inches, feet, feet. So in real life, 44 feet. For a school project, Leo is making a model of the Statue of Liberty. He's using a scale of 2 centimeters is 3 meters. So this one isn't the scale factor, but it is a scale. It's not a scale factor because it's not 1 to something, but we can still use it. So I've got 2 centimeters to 3 meters. This is the drawing. This is the real. So let's see, the Statue of Liberty is 93 meters tall. That's real. So meters, now I've got 93 meters. And now, this time I'm looking for the top. But it's the same method. 2 times 93 equals 3 times x, or just 3x. So 2 times 93 is 186 equals 3x, and I'm going to divide by 3 to get x by itself. So 186 divided by 3, and I get that x equals 62. So I'm going to put 62 right here, and I'm thinking, what's my label? It's going to be centimeters. So my drawing is 62 centimeters.